Hello, Year 9. Today we're going to have a look at the gradient of an interval. So we're pretty much looking at all of this stuff. I pretty much put a description in here of what to do, although I did grab it out of the nested dot points. So we need to find the gradient interval. It says plot 2 points in the Cartesian plane and join them to form an interval. We'll actually already have our intervals formed today. Tomorrow we'll look at, or next lesson we'll look at perhaps plotting 2 points as well. But we are going to form the right-angled triangle beneath the interval that we already have by drawing a vertical line from the high point and a horizontal line from the lower point. And then we are going to use the interval to find the relationship gradient is rise over run, where rise is our change in y value and run is our change in x value. So let's go and have a look at our notes. So there's our learning intention, find the gradient of an interval. So the gradient is the slope of a line. We use the letter M to stand for gradient. So whenever we see M in maths, it means the gradient. Now, gradient is a change in the y coordinate over the change in the x coordinate, or commonly we hear it all the time, rise over run. So let's have a look and see what we're going to do. This is a bit similar to what we were doing when we were finding the midpoint. If the line is on a graph, so we've got a line on the graph already, we're going to look for where the line goes exactly through a corner, where it's exactly whole numbers, like the 0.23. We don't want to have 2 point something or 3 point something. When we find those 2 points, we're going to draw a vertical line from the higher point, horizontal line from the lower point to make a right-angled triangle. After we've got our right-angled triangle, we're just going to count the number of units on the vertical line side, write the number next to the vertical line as the rise, or just the change in y value as the rise. Then we're going to count the horizontal length and write next to the horizontal line as the run. Then we're going to just write gradient M as the fraction. M equals the y length on the x length, or the rise on the run. And then the last thing we're going to do is we're going to have a look at it and we're going to see, now if it's going this way, if it's going up, it's going to be positive, and if it is going the other way, if it is sloping this way, it's going to be negative. And so we're going to throw that sign in front of our fraction right at the end to get our gradient right. So let's have a look at our first example. Our first example, we're going to look at the gradient of the following lines. A, we're in. So when we look at this, we're going to look for where this thing is going exactly through points. And you can see there's a few here. It's going through. I could choose any of those, but I chose this one and I chose this one. And then what I did was I drew a triangle underneath and I measured, or had a look, I counted, and I went 1, 2, 3, 4, 5, 6, 7, 8, 8 there, and I went 1, 2, 3, 4, 4 there. So I wrote my numbers next to the lines, and then I needed to write the rise. This one needed to go, changing colour, this one here needed to go up the top, and the other one needed to go down the bottom. Looks like everything is gone green, I'm not quite sure why. Okay, and so it was 4 on 8. Now this is an exercise. Gradient in this topic is going to be an exercise in simplifying fractions. We want to put them in their simplest form. So every time we get one of these, I recommend you use that A, B, C button on your calculator, and you put 4, A, B, C, you put 4 and 8 in, which in your calculator is usually got 4R8, and push equals. And then write down what the fraction is as your answer. So this is a really good topic to have your calculator with you all the time and to be using it as we work through. Now, our last thing that we were meant to do was looking at seeing what the sign was. And so when I look at the sine, I can see that, or when I look at the slope, it's sloping up. It's going that way. And so sloping up is positive gradient. So my m is plus a half. We don't put the plus. My gradient is a half. So I look at our next one, which is a long way away. Here it is. I'll drag it up later. Now what we've got is we have this next one sloping again. I'm looking for some points, and there are others I could choose. I can see, I reckon that's on a point probably where it's going through as well. Maybe, maybe not quite, but I do know because I drew them that here's a point here it's on, and here's a point here where it goes directly through. I can see that they go through. Count them up again. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. 11 in the vertical direction. 1, 2, 3, 4, 5, 6, 7. 7 in the horizontal direction. So vertical on top, horizontal on the bottom, fraction 11 on 7. Put that in my calculator, A, B, C, and it just stays there. It won't change. So my gradient here, what I've done wrong here, once I go through and change my notes, when I do put that in my calculator and push equal, hopefully it's going to go 1. I'm going to have something that goes 1R, 4R, 7. And it's going to give me 1 4/7 because, again, we are meant to be putting these things in simplest forms. We're meant to be simplifying our fractions when we get them, not leaving them as 11 on 7. This time when I look at the sign, I see it's going downhill, so it's got a negative slope. So my answer is minus 1 and 4 on 7. So since I had that one, I didn't actually need to do my final example. I did my final example because I wanted to have one where I had to simplify the fraction, but looking at this final one, same sort of scenario. I've got my line, I've looked for points. There's one there, there's one there. This one has got lots. Another one there, another one down there. But anyway, for the first one that we've got, we're going to come across here. 2 up here, 1, 2, 3, 4, 5, 5. So 5 on top, 2 on the bottom. Gradient is 5 on 2. 5 on 2, put that in my fraction, push the equal sign. So put it in with the A, B, C, get the fraction in as 5 on 2, push my equal sign, it will come up and it'll go something like 2R1, R2, that's 2 and a half. Then have a look at my slope. Slope is going up, so it's positive. So my answer is M equals 2 and a half. Okay, so with the examples, there's a couple of sheets in here. Now these ones here, if you want to, you can have a go through and whip through and do those gradients, positive or negative. Now all of these ones here, I have put into the exit ticket for today. And so what that leaves you to do is do them on the Microsoft form. You'll be able to read them. Make sure you've got your calculator, because see all these things here, they're all for you to be able to go 6 on 2 and then end up with 3 on 1, or sorry, that one's not going to be that. This one will be. This will be, say, 6 on 2 and end up as 3. This other one up here might have been 5 on 2 or 6 on 4 or something. If I get my raw rubber to work, perhaps that one was 6 on 4, 3 on 2. So the free-form sheet is scaffolding you to simplify your fractions. You will need to simplify your fractions as well when you put them in. I haven't tried to trick you, so I pretty much simplified all the fractions anyway in most of the questions. So your exit ticket, you're going to come here, you're going to, hopefully you are going to be able to click on it. That works. Well, it looks for it's going to take you here. You're going to do these. So the first 8 questions is just asking you to choose whether it's a positive or negative gradient. So that's the first 8. You just look at them and choose. And then from here on is where you're going to do the value of the gradient in simplest form. So have your calculator out, count what the rise is, put that as in the fraction over the run, push equals and see if it comes out to one of these things. You'll have to choose your sign. You'll need to work out whether it's positive or negative. and put your sign in separately. And so I think there's 9 of those for you to do as well. So that's a pretty efficient way, since I've cut and pasted them in, efficient way for you to do quite a few of these problems. If you get through all that and you are looking to do a bit more, these ones here are ones you should have a look at, because these ones here you've actually got to draw your own triangle. So at least that'll give you some practice in drawing your own triangle as well, and then counting the squares, etc. Okay, so that's what I'll get you to do today. Have a great day. Hopefully you did well in your assignment.